Hello students, welcome to Eshwari Thaniksha channel. Students, today I'll be teaching you one trick to solve all kinds of questions which will be asked on molecular orbital theory. So let any question come. So you will be able to solve within few seconds. So I'll teach you a beautiful trick at the end of the video. So students, first let us see what are the types of questions which will be asked on this theory. So you can see this is the first question which I have taken from 2017. So what is the question here? Which of the following pairs of species have same bond order? So here you can see species which are given. You have to find which is having the same bond order. And second question, you can see I have taken from 2018 paper. The question is, which one has highest bond order? So here some species are given. So you have to find which will be having highest bond order. So here one thing what you can see in common is they are asking bond order. So you have to find bond order. So here you can see the four important points, that is the four important questions which can come from this concept is they can ask about bond order. Just now we have seen. So species will be given like this and you have to find their bond order. Second is they can ask you to find bond length. So same type of question. Species will be given like this and they will be asking you find bond length. Third type of question is find their stability. So some species will be given. You have to find their stability. And fourth is they can ask find whether they are diamagnetic or paramagnetic in nature. So these are the four kinds of questions which will come on this theory. So already I have made two videos on that. So you can go to the playlist and you can watch those videos. I have taken some examples and I have explained. So here I'll teach you one more super trick. So using that, so there is no need to calculate the bond order also. Directly you can write the bond order. So here the first trick I'll teach you. So the first trick here is, so make a note of this. So this will be very useful for your examination. So what is the trick is? So bond order, if it is increasing, then stability also will increase. And if bond order increases, then bond length will decrease. So this is one of the super trick. So just you have to find the bond order. If you find the bond order, so you can see the relationship between them. So if bond order is increasing, then easily you can write their bond length. Or if bond order is increasing, you can easily write their stability. So make a note of this first trick. So if you find one, easily you can solve. So find one and easily you can solve these three types of questions. So now the question is how to find the bond order. I told you if you know bond order, you can solve these kinds of questions. But how to find the bond order? In last two videos, I have taught using a formula how to find the bond order. But today, so no need to remember that formula also. Directly I'll tell you how to know their bond order. So how to remember their bond order is, so suppose the number of electrons in the given species is 10. You have to count the total number of electrons. If it is 10, then their bond order is, I'll just write once again here. So number of electrons. So total number of electrons, and here I'll write the bond order. So just count the total number of electrons in the given species. So if it is 10, then their bond order is 1. If it is 11, bond order is 1.5. If it is 12, their bond order is 2. If it is 13, then bond order is 2.5. If the total number of electrons are 14, then their bond order is 3. So here this is the highest bond order you will get. If the total number of electrons are 14, so you will get the highest bond order, which is 3. Next, so we have taken 10 electron, 11, 12, 13, 14. So next 15 electron. So I'll write here 15 electrons, 16 electron, 17 electrons and 18 electrons. So this is also number of electrons. So here what is common is, if the number of electron is 13 and 15, their bond order will be 2.5. So if the electrons are 10 and 18, bond order will be 1. If the number of electron is 11 and 17, their bond order is 1.5. If the number of electrons are 12 and 16, their bond order is 2. So this is common for this two. So this is common for this two. Same way, this is common for this two. Again, this is common for this two. So only 14, this is the highest bond order. So this trick you remember. So no need to calculate using the formula as well. So now using this trick, we are going to solve these first two questions what I have shown. So let us solve now. So here they have asked here, which one have same bond order. So let us see which one is having same bond order. So now first find the total number of electrons. So here oxygen will be having, one oxygen atom has 8 electron. So O2 means it is 8 plus 8. So total 16 electrons. And NO plus, N has total number of electrons is 7. Oxygen will be having 8. So 8 plus 7 is 15. Here there is a plus sign. So here there is a plus sign. So now 15 from 15 remove 1 electron. So if you remove 1 electron, how much you will get? You will get 14 electron. So totally you can see here oxygen is having 16 electron. NO plus is having 14 electron. Then what will be their bond order for 16 and 14? So 16 and 14. So you can see 16 is having bond order of 2. 14 is having bond order of 3. So both are different, 2 and 3. Here the question is which is having the same bond order. So here the bond order is different for this. For 16 the bond order is 2. For 14 the bond order is 3. So both are different. So first one is not the answer. So we will see for the second one. So second one, carbon has 6 electron. Nitrogen has 7 electron. 6 plus 7 is 13. And here minus sign indicates they have 1 extra electron. So how much you will get? 6. 6 plus 7 is 13. And 13 plus 1. 13 plus 1 will be 14 electrons. And next one. Carbon has 6 electron. Oxygen has 8 electron. So 6 plus 8 is how much? 14 electrons. So 14 electron. So both are 14 electron, meaning what is their bond order? Their bond order is 3. So 3. So Cn minus has bond order 3 and CO also has bond order 3. Then what is your answer now? So the answer will be 2. Sorry, B. So this will be the correct option. So is this easy for you to solve? So now which one, second question, if you see, which one has highest bond order? So same way you have to find which one is having highest bond order. What you should do? First find the total number of electrons. After you find the total number of electrons, use this trick. So it is easy for you to remember. See from here 10, 11, 12, 13. Just increase 0.5. 1, 1.5, 2, 2.5, 3. So after that, so here 14 electrons. After 14, write in the reverse order. 15, 16, 17, 18. So this much you can easily remember. And highest bond order will be for 14 electron. So easily you can remember this trick. So find the total number of electrons and easily you can find the bond order. So once you know the bond order, if they ask their bond length, so using this relationship you can find their bond length, and also stability you can find using this relationship. So is this easy to find, solve any kind of question which is given on bond order, bond length and stability? So second question I have taken from 2018. So you have to find which one is having highest bond order. So I'll give this for this as homework to you. So try this and write the correct option in the comment section whether A is correct answer, B, C or D. So you have to try this and write your answer in the comment section. So now next is diamagnetic and paramagnetic. So how to find a given molecule is diamagnetic in nature or paramagnetic in nature. So to find that, so you should know this molecular orbitals. So here you can see if electrons in a molecule is up to 14, so you will be using this arrangement. So molecular orbitals will be arranged in this order. So you know that molecular orbitals of two type. Bonding molecular orbital, so BMO, bonding molecular orbital, and anti-bonding molecular orbital. So here if a star is present, can you see this star? If star is present, it is called as anti-bonding molecular orbital. So without a star, it is called as bonding molecular orbital. So this is bonding molecular orbital. This is also bonding. So this is also bonding molecular orbital. This also bonding molecular orbital. Anti-bonding star if it is there. This one, this one, this one and this one. These all are anti-bonding molecular orbitals. So count the number of electrons. If it is up to 14, meaning is it can be 8, 9, 10, 11. So up to 14 you have to use this arrangement. More than 14 electrons, you will be this kind of arrangement of molecular orbital. So what is the difference in this two is, here you can see 2 sigma 2pz. So sigma 2pz will come after pi 2px and pi 2py. Whereas here in the second case, this will be shifted front here. Can you see here? This is coming before pi 2px and 2py. Before that you can see this sigma 2pz, whereas here it is after. So this is the only difference. Remaining everything will be the same. So now let us take some example and understand how to find whether the given molecule is diamagnetic in nature or paramagnetic in nature. So the first example we will take O2, oxygen. Whether oxygen is diamagnetic or paramagnetic in nature. Let us find out. So here oxygen, how many electrons are there in O2? One oxygen has 8 electrons. So 2 oxygen means 8 plus 8. So totally how many electrons are there? There are 16 electrons. So now which one you are going to use? Whether it is up to 14 or more than 14. So it is 16 electron. So you will be using this one. So now write 2 electron in each molecular orbital. So 2 here, 4, 6, 8, 10, 12, 14, 15, 16. So can you see here unpaired electrons present? So students, here these are called as degenerate orbital. So here can you see the symbol? So here equivalent sign meaning is they are degenerate orbital. So degenerate orbital means they are having equal energy. So equal energy. So if degenerate orbitals are present, then you have to write 1 electron in each orbital. So if unpaired electrons are present, can you see unpaired electron present here? 1 and 1. So if unpaired electrons are present, then they are paramagnetic in nature. So here you can write O2 is paramagnetic in nature. Paramagnetic. So second example we will see nitrogen. One nitrogen has 7 electron. 2 nitrogen means 7 plus 7 which is 14 electron. So if it is 14 electron, which one you will use? So you will be using the first one. So this one you will use. So 14 electrons we have to fill. 2, 4, 6, 8, 10, 12, 14. So you have filled 14 electrons. Can you see unpaired electron? So there is no unpaired electron. All are paired up. So if all are paired, it is called as diamagnetic in nature. So N2 will be diamagnetic in nature. So diamagnetic in nature. So if you know this much, it is enough. So you can ask any type, you can solve any type of question within few minutes. Is that very simple? So let it be bond order, bond length, stability, diamagnetic or paramagnetic in nature. So know this much trick. So that is, remember first trick, Remember this second trick and this one. So up to 14 electron and more than 14 electron. So if you know this much, you will be able to solve any kind of question which is given on this bond order, bond length, stability and magnetic property. So students, I hope you like the video. So if you like the video, please subscribe the channel and also share this video with your friends. In the next video, let me make tricks on other concept. So if you are finding any concept difficult, write in the comment section. I'll make video on that concept. So all the very best students. Only few days are left for NEET examination. So prepare well for your examination.